Welcome everyone to another code live stream. Today a little bit light after work talking here. And also, I have one thing I already know. I like the external camera more, but I haven't unpacked it yet. So yeah, MacBook camera there. So code refactoring. So a little bit, so it's basically stories from us here at Exacode. And this week we wasted way too much time with old stuff, recurring theme, right? Old stuff, mainly our scan software, right? One of our better selling products, Exact Scan. Don't delay, try high-speed scanning today, right? For your paperless needs. And similar to my open source work of all of those stuff, right? I've even started this with open source. Sane Avision backend for Taiwanese located OEM scanner business. And in the meantime, so we support over 500 scanners, right? And it brings me to code refactoring. So we have huge challenge of keeping decade-old scanners alive and working professionally, similar to our other vintage and hobby stuff. And this brings me today to code refactoring and basically aka wasting our times. I wonder how useful is code refactoring and how much you should do it. Probably it's usually overdone, but leave in the comments below. Only wanted to after work talk in my experience. So we don't do that much. All right, we don't have that much time and money. And what is it? So in computer science and design, code refactoring means you write some code, right? And eventually you notice that it's not that maintainable anymore. You can't read it anymore. You can't integrate new features. Or other surrounding stuff changed, like new security. So you might want to refactor this for the next hardware generation, Intel, NVIDIA, AMD scanners. And also security, right? Maybe some new algorithms. And for those, maybe you need to refactor a little bit more because new algorithms like PDF, right? Think PDF, and it's like, yeah, some design mistakes were made. And it's like you need to refactor a little bit more because the new security algorithms do not fit your APIs entirely. So that means you change some code, like you have some classes, right? I don't obviously want to show my commercial code, but think Linux kernel, right? Here use gadget stuff of changes. Oftentimes that means also like blocking. Oftentimes that refactoring might be reworking classes, API facades, proxies. You might want to split one, right? Your class might become too large to maintain. You might split this in a couple of smaller classes handling some things. And of course, all of the stuff you need to change a lot of code, right? You separate a class into multiple, even Linux kernel, right? Even C code, C with classes. Even Linux kernel classes there often rather, even in C, right? Some classes with structures, moving some members or even renaming, right? Maybe it might be as simple as like our naming sucks big time, let's freaking rename it, like in the Linux kernel all the time. And so this is renaming, right? Usually you start with like small rename, small changes. You might do small cleanups or like better locking, right? Like more automated locking or different locking because multi-threading. These are all this kind of stuff in refactoring. And I mean, we don't do that much because I said we are not that rich to constantly, because that is the issue, right? Benefits like maintainability, readability, extendability, new features, but drawbacks, disadvantages cost money, right? Time and money cost more money, and testing, right? Might break stuff. Linux kernel and other regressions here constantly breaking stuff. And there are some automations for that, like obviously renaming, depending on your language and integrated development environment, you can rename some stuff, but renaming is not a sophisticated form of refactoring, of course. Even splitting classes and stuff, there might be some automation and helpers, but usually my experience doesn't work the best. But it is also not only that, right? So in our case, we don't do it that much. And one thing we did this somewhat is, of course, our scanner drivers, right? I've seen this with, again, I have seen some code, I have some code, but NDA and certainly can't. The big vendors, like, and I better don't mention too much. But anyway, like similar to AMD GPUs or NVIDIA GPUs, every generation they change stuff, right? Also with scanners and so on. And similar to Mesa and the Linux kernel, you constantly basically refactor your, for example, 3D graphic interfaces for new features or performance optimizations. And what we tried to do is, I mean, obviously we support all those 500 different scanners in some driver architecture. And that is something that the Windows vendors don't do, right? I've seen in Windows, they do not have the work methods of using source management systems like Git that much. 10 years ago, they were carrying their source around with USB sticks and stuff. It's crazy stuff in the Windows land. And also I've seen that the vendors, they reinvent the wheel a lot, and they often create, they copy for new model, like new NVIDIA chip or scanner or printer. They copy that and start a new project. And what many, like similar to open source projects like we do, we have one driver infrastructure. And their refactoring is often new features, right? You constantly integrate differently new features for each generation of new GPU or scanner, for example. And so we actually try not to touch it that much, because what the issue is, similar to hardware, I've seen in the Linux kernel, right? Constantly quirks and hacks and bugs and so on. And this, of course, also happens with our software here. And often we don't even want to change it, right? The problem is the vendors bring out some new hardware and we need to adapt our software. And often they change random stuff, as you see on the Linux kernel also, constantly like, why did they do that? Often they change it. I mean, often we don't even find a reason why they changed it. It's just done a little bit differently. So we need to keep changing our infrastructure a little bit. And the problem is supporting old hardware, right? And we try to be very careful not to change code flow of other hardware, but eventually it happens, right? This is also the problem. So the question of today, right? How much refactoring is it even worth it? Because turns out when we pissed off now some customer there at the end of the world, was like, it doesn't freaking work anymore. And that is the real life consequences, right? That we need to deal, and like everyone in software needs to deal every day. You change some stuff, you test it, everything's amazing, and then some customer at the end of the world like, what you're freaking doing, unprofessional stuff. The usual customer yelling at you. And this costs enormous money, right? This is my point of this video. It takes so much time to develop. So refactoring, right? You first spend the time of maybe review the stuff, make a plan, hopefully, execute the stuff, and then hopefully test the stuff. And that's also the problem, right? Testing with old hardware, right? Getting all the NVIDIA GPUs out of the P3, SG Octane, or the freaking scanners. In this case, it was even a freaking A3 scanner, so I need to get to someone had to get to our QA storage, archive, get the freaking scanner out, some 5-year-old scanner and stuff, even a 3 huge piece of heavy machinery. And it's like, it really doesn't work anymore. And the crazy thing is, so this wasted multiple days, for example. Usually it doesn't even happen so often for us, right? Because we're professional and try to test stuff. And testing with hardware is difficult, right? I have the impression most Windows companies don't really have that much testing. Open source and small companies like us at times have way more testing, but the challenge is also testing with hardware, right? And we have here some scanners and stuff, but you can't depending on your resources, but like automatically testing 100 scanners is a little bit difficult, especially with paper feeding and stuff. Flatbed scanners, of course, you can test automatically somewhat, but otherwise you need to automate putting paper in there. So either you have a huge setup, but even that costs enormous monthly rent and space, obviously, through that you can't use otherwise. And long story short, working with hardware is highly expensive, right? Not every year the changes, hardware revisions, but then also the surrounding support and testing, and that's really adding up, right? We are reaching somewhere at the point that at 99 euros, our exact can cost 99 euro, right? And this is somewhat kind of too cheap, right? We are reaching the point that all the testings, all the new macOS, even all Apple Silicon, right? Needless changes from Apple side. Then every macOS release, they break stuff, remove stuff, deprecate stuff, and break USB stuff. And then also for our customers, saving them money, not buying a new scanner, and the environment, not e-wasting this stuff. It's a huge effort, right? Means also the hardware, maybe it shouldn't constantly change as much, and there should probably be more standards. Imagine if there would be a standard like USB storage or human interface devices, there would be some scanner class thing, which doesn't exist. There is no some Twain direct driverless stuff, but that is networked and not really USB, although you could tunnel network over USB, but this makes the stuff so expensive, right? And especially all the surrounding stuff, and what also people don't understand, right? People find 99, thankfully not all, but many people find 99 euro freaking expensive, like nearly get a Windows or other. But yeah, development, support, testing, and refactoring. And so in our case, so what we try to do, similar to a little bit like the Linux kernel, obviously having some feature flags, right? So what we try to do in the infrastructure is having some, I mean, obviously you can query those devices, vendor specific, like supporting that and that feature. But one thing is similar to seen in the Linux kernel, right? Often, sometimes those, at least probably with every scanner, there are some bits wrong. Nearly with every scanner, at some vendors more than others. And so obviously we conditionalize this stuff, like this feature and that feature and stuff. But sometimes you also realize there were some bugs, right? Sometimes, as seen in the open source space, sometimes you write it, you test it, it works, and then only later it's like, oh, it only worked by accident, right? Because that bit was wrong and that was inverted in the test, and then you refactor that, right? It's like, yeah, dude, it's obviously a typo, and you refactor that the logic is correct and not inverted or stuff like that, or you used the wrong bit, right, accidentally in some bit field definitions of hardware protocol stuff, and it only worked by pure chance and accident, and then you refactor this or fix the bug with using the right bit, and then some other scanners have this bit actually also gets this in the hardware wrong, right? Long story short, all this stuff is adding up, right? Crazy complexity on all those levels, and even in our case, so we had, I think, nearly 3 different regressions, right, in one of those specific scanners, and this was very specific to those scanner modules. But it only happened because we optimized stuff. So like one regression was because we optimized stuff, made some kinds of image processing algorithms way more efficient. And so that was by pure chance of complex coincidences causing one bug. So basically I think there was nearly 3 regressions. Another regression happened because another optimization, we optimized for some other scanners to scan faster using some, I don't want to, I could tell you precisely what, but I don't want to tell our competition, obviously, right? But basically we for some scanners discovered some specific set of features that were not really advertised but were working, for example. And so we used that on those other scanners that worked and made them scan faster in certain image processing settings. And so for this scanner that didn't work, right? So we optimized something, we tested something, it worked for all the other scanners. And this scanner was not that popular, obviously, expensive A3 scanner. And yeah, for that scanner it didn't work, right? So that was the second regression. Then there was also a third regression of pure refactoring of like, yeah, dude, this is getting too complex and so moving some code around, sorting it a little bit nicer and stuff. And it's like, yeah. And then we double mirrored some data because the scanner said it needs mirroring, but some other image processing already because the scanner sends the data so garbled for cheap hardware reasons. So yeah, we double mirrored that. So that was because of code. This is exactly those disadvantages, right? It's also outlined here on Wikipedia with challenges and testings. Like, yeah, you support 500 scanners, of which you have nearly 100 scanners in quality assurance stock. And you obviously can't unpack each of those. That would be way too expensive. If we every year would retest every scanner for regressions, then you couldn't afford it anymore, right? And we would need to charge 99 euro or so. And obviously people already constantly complain to us that 99 euro is already too expensive. Yeah, leave in the comments below. This is like, we try to avoid it, and yet we obviously, we all are humans, and especially working with such quirky hardware, certainly doubles the chances of hitting stuff. And that's basically a little bit after work talk. Leave in the comments below. My tip is, for me, that means because of the wool stuff, it pissed off some partner of us selling scanners somewhere at the other side of the wall. So they got angry. They have, I mean, by pure chance, they even had 2 customers. So sold 2 new A3 scanners to 2 different customers. They both had the same problem, obviously, because of software regression. So they annoyed 2 customers of relatively expensive scanner, A3 thing, not the cheapest thing. They were annoyed, right? But this is the consequence, right? The disadvantages of software, of ever-changing stuff, which we avoid, and testing. It's like, if you change too much, if you don't test enough, and then at the end you have angry customer, right? Or, I mean, thankfully nobody died from that, obviously, but software warranty. For me, the whole thing, especially with getting this scanner out of QA stock and like with working from home, someone needs to come to the office, needs to go to the storage, and so yada yada. So this is highly expensive, right? So even just fixing this bug, fixing these regressions, all in all was so easily probably 500 euro gone in total with all the QA escalating this, finding out that this is the issue. Like it's not like one customer, it's not like one Mac, like one USB thing, like one Apple Silicon ARM thing. It's like escalating this, finding out, like here, reporting. Eventually, some weeks are gone, multiple emails, getting the hardware, debugging through it, remembering what was 5 years ago with the scanner, what is this quirky thing. It's like, debugging this, fixing this, QAing this. Hopefully, it doesn't break anything else. And for me, the takeaway is we will try to do it even less, right? Because honestly, we can't afford it anymore, right? This is, I mean, we avoid it like the plug. We really avoid it. We retry always hard. Like new features, usually like similar to the Linux kernel, right? Also only cooking here with water and certainly not C though. But like similar to the Linux kernel, like some feature table thing, quirks and overrides, and like new code and new features only if hardware supports that feature, obviously, right? And although one thing and that is also the thing. I mean, on the Windows side, if the vendor copies the driver and always works with one fork, it also has disadvantages, right? So the Windows vendors usually, if they sold something, they never improve it. On our side, it's different. You might or not only might. I mean, usually over the lifetime of ExactScan and some scanners, usually every other quarter or year, you might get improvements, right? We might find new tricks for performance. We have better image processing and obviously supporting 20 years of scanners. You don't get this on Windows at all. So that is a disadvantage. There on Windows though, usually at least, I mean, sure, NVIDIA also has some somewhat generic driver for a couple of cards except legacy. But yeah, everything has advantages and disadvantages, right? Either you never touch it, then you have no improvements, no new features, no security fixes. And otherwise, if you improve it, then you also have sometimes regressions. So every coin has 2 sides, and everything has advantages and disadvantages. For us though is, as I said, we try to avoid this, always conditionalizing this stuff. I wanted to say, so we try to generalize this stuff. Unlike on the Windows drivers, the Windows driver is usually hard-coded for one model. They usually copy this and then edit all the stuff away or add the new stuff, and obviously the overhead of maintaining multiple forks, multiple things, and generalizing this. But we will be even more careful, right? Because you need to optimize your software development, right? This is our real business decisions. Management decisions, right? Our management decision takeaway from these days of this pesky regressions is we need to be even more careful, right? Because it makes no economic sense to spend so much after sales, or especially, I mean, these were actually 2 new sales theoretically, but they also see, right? I mean, the hardware costs some €1,000, that's 99 euro for our software in relation. But the reseller gets some discounts, and it's even less than 99. Also 99 includes tax. So at the end of the day, you speak about €100, right? Causing, I mean, this is in this case a loss situation here. But that's also life, right? I mean, obviously from some customers you never hear something. Every day you sell some licenses. From most you never hear. This is of course a calculation that, and also for future sales, right? I mean, for those 2 customers, it's no loss business, unfortunately. Welcome to the YouTube business of making loss, but in the long run, of course, you need to fix bugs, right? I mean, obviously, otherwise you continue to make a loss because you don't sell software anymore. But yes, these are business decisions selling software, and our business decision is we don't want to deal. I mean, obviously, we don't want to deal with angry customers. We can't really test more because we already test a lot, and we can't. Due to that, it's hardware, right? If it would be software and algorithms, I would write more test cases because 100% code coverage. But given the hardware nature of this, it's like, yeah, the office is already full. I can't stick here scanners everywhere, right? It's already in Octane and P3 and stuff. And there's a limit of how much stuff you can constantly have here unpacked to automate that, right? Otherwise, you would have like 30 scanners, or I mean 500, right? But even selecting like the 30 scanners for the most code passes, it's like even that is somewhat unrealistic to test on, even on a monthly basis, right? If you are super rich like Oracle or Apple, maybe you can do that. I mean, given Apple's #peakbugs, maybe they don't do that though. But anyway, yeah, management decision. Try even more for us. It makes no sense to I mean, this is for too much disadvantage, right? And obviously we will try. I mean, we will try to keep our code maintainable and readable and stuff. But going forward, we need to be even more careful to touch code paths that are not as regularly tested, right, with new features. So even better takeaway from us this week, even better feature selection, scanner selection, type, hardware type selection to avoid this and save our customers' nerves and satisfaction and our time and money, right? Because at the end of the day, who wants to constantly hunt regressions? And also what I regularly criticize in Linux kernel, right? And in my opinion, and I mean, as we have, I would say really few regressions. I would say the Linux kernel has really many, and this is also what I really regularly criticize of. This is exactly their ever-changing stuff, right? And then people constantly, but yeah, here's the regression, there's the regression. I mean, if we just go to the changelog here, other not only ours but other real-world examples. Regression, right? It's always like regression, right? Just, but I said it before. Linux kernel for me, and that is also the thing, right? It's mostly pointless, right? What is I mean, especially the renaming, right? Renaming mostly pointless, or like tiny little bit of this argument, API changes. But leave me in the comments below, right? What are your experiences, recommendations? For me, I would say only do it if you really, if there is a real business pressure of code gets way too expensive to work with, then obviously you eventually need to refactor it. Or you have way too many bugs or something, like both things we don't really have. And otherwise, if you make a calculation, cost time and money, and you obviously see from that, is it worth it, is it not? Leave in the comments below. That's it for today. I hope you learned something, and it's like, this is also, software development is not always coding, it's also management and planning and business calculations of what makes sense and what doesn't. I hope you learned something. Don't forget to share and subscribe. Leave in the comments below. Especially, I think I don't like the camera angle. It's like this comes from I talk live streaming without a proper camera, and that's like so much to. And I have to. But anyway, leave me in the comments below. Audio, video, and stuff. How many drop frames are freaking 200. Only 295. Yeah, back in the office. Vodafone. Freaking subscriber know what I'm talking about. 4 Mbit. Yeah. Anyway, that's it for today. I hope you learned something.